Hello, I'm Mrs. Neill, and this is lesson number 10, horizontal and vertical lines and parallel and perpendicular lines. Some of the topics we're going to talk about today is horizontal line, a vertical line, parallel lines, and perpendicular lines. And let's go ahead and start. I've got an example right here on a piece of paper. Now it would be helpful if you had some graph paper with you so that you can draw the diagram also. It makes it go a little easier. This is asking to write the equation for a horizontal and a vertical line that contains the point 3, 2. So I've got the point 3, 2 already graphed here. And we're going to first do a horizontal line. So what I'm going to do is draw a horizontal line through that point. Remember, when you're thinking about horizontal, think of the horizon. If you go outside and you're looking at the horizon, you're going to be looking to your right and then to your left. You're not going to be looking up or down. The horizon goes from your right to your left. So, horizontal line goes from right to left also. So, right here, if I have a horizontal line, notice that every point has a y-coordinate of 2. So, if I graphed 3, 2, I could also graph 6, 2. That would be right there. How about negative 4, 2? How about 0, 2? If you notice, every value of your y-coordinate is 2. And the line intersects the y-axis. This is the y-axis right here, and it's intersecting it. So a horizontal line is going to be y equals 2. Note that a horizontal line has 0 slope. It's totally flat, so it has a slope of 0. Let's go on. Let's look at the vertical line. Now, here's our original point right here, and I'm going to do this in a different color ink. So I'm going to draw a vertical line. Vertical goes up and down. Don't forget your arrows. Please put those on there. So we're looking at the dark line now, not the red one. A vertical line, notice that every point has an x-coordinate of 3. I have graphed the point 3, 2. What if I pick another point? How about 3, 7? So I go 3 and then up to 7, which is right there. How about 3, 0? 3, 0. How about 3, negative 4? There we go. If you notice on a vertical line, every x-coordinate's value is constant. It's 3. And if you notice when I draw that vertical line, which axes did I intersect? I intersected the x-axis right there. So a vertical line in this example would be x equals 3. Note, a vertical line has no slope. Just think of, can you drive your car on that line? No, I can't. No, there is no slope, so there is no way I'd be able to drive my car on that line right there. There's a big difference between 0 slope and no slope. So make sure that you understand that they have two different meanings. This slope is no slope. Let's do one more example. And then we're going to go on to something else. All right, I've picked the point 2, negative 6, and I've graphed it right here. Let's do a horizontal line through the point 2, negative 6. Now, I'm going to go ahead and draw my horizontal line to give me a visual. Put arrows on it. Okay, which axis did it go through? When I drew that line, I went through what? I went through the y-axis at the point -6. And I graphed some points here, and notice how -6 is constant in my table here. So the horizontal line through point to -6 is y equals -6. Let's go on. Let's look at a vertical line through the point to -6. Did a horizontal, let's now do a vertical line. Do that with darker ink so it looks a little different. Notice on this vertical line, which axes did I intersect? I intersected right here at my x-axis at 2. Also, I did a table. Notice that all the values of x are constant. No matter what is y, the y value x is going to be 2. So this vertical line is the vertical line x equals 2. There. All right, let's go on to parallel slope. Now there's two kinds of slopes we want to look at, is parallel slope and perpendicular slope. So parallel, let's do that one first. I will honestly tell you parallel slope's a little easier than perpendicular slope. So let's find the slope of both parallel lines shown below. I've got line M and I've got line P. And I want to find the slope. Remember, slope is rise over run. We've studied that already. So I'm going to take the slope of line M and I'm going to start at this point and I'm going to end up at that point. I've already just selected those 2 points. And I'm going to rise up 6 positive and I'm going to run positively 8. So the slope of that is 6 over 8. But if you ever have a slope that's a fraction like this, you can reduce that. They both have a common factor of 2, so it'd be 3 over 4. So the slope of this is 3 over 4. Now let's go to line P and find its slope. And I just picked these 2 slopes to find, these 2 points to find the slope. I'm going to rise 3 positively and run 4 positively also. So that is 3 over 4. If you notice, their slopes are the same, and that means that they are parallel. Parallel slope means they're the same width from each other. I always try to think of, when I think about parallel lines, I think about railroad tracks. Railroad tracks always have to stay parallel from each other. What happens if they're not? The train's going to fall, is going to derail or fall. Also, like when you're skiing, snow skiing or water skiing, you have to keep your skis parallel. When you're turning, you have to turn them at the same time. If you don't, if you cross them, what happens? You fall down. So think about railroad tracks when you're thinking about parallel lines. They have to be the same distance apart. Now let's write the equation of the lines in slope-intercept form. That's y equals mx plus b. So this line would be y is equal to 3/4 x plus, let's see, what's the y-intercept? 1, 2, 3, it's around 4. And this line, our line P, is y equals 3/4 x, and its y-intercept is 1, 2, 3 minus 3. What do you notice about the y-intercepts of parallel lines? What do you see? These y-intercepts are different. They're 2 different numbers. They have the same slope, but they have a different y-intercept. What if the y-intercept of this line was positive 4 also? What if this said y equals 3/4 x plus 4? That would mean they would be exactly the same line and they'd be sitting right on top of each other. They'd be coinciding. So as a result, to have 2 parallel lines, you can have the same slope but different y-intercepts. Alrighty, let's go on and talk about perpendicular for a little while. Perpendicular lines, remember perpendicular lines form right angles. So if you've got two perpendicular lines, they're going to form a T, and you're going to be kind of looking for right angles right there. Does that look like that's a right angle? How about that right down there? That's a right angle too. So their slopes, one's going to be going one way. You notice that's going in a positive direction, and the other one's going the other way, which looks like it's in a negative direction. So let's count the slope on line S right here. We're going to do rise over run, and this one is a positive slope. Notice it's rising on the right, so it's positive slope. So it's a rise of 1, 2, 3, 4, 5, and a run of 3. Now let's look at the slope of this line going this way. I've already marked 2 points, and I did a rise positively of 6, but I'm running to the left, so that's a negative. So that's negative 10. So I have positive rise, negative run. So that's going to be 6, negative 6 over 10. And then when I reduce that, I can reduce that by 2, I get negative 3/5. There we go. So the slope of that line was negative 3/5. These two lines are perpendicular. When I multiply their slopes together, what is going to be their product? Let's look at that. So if I take 5/3 times negative 3/5, what I get is negative 15 over 15, and I get negative 1. So if you think you have perpendicular slope, what you do is you multiply their product. Multiply them together and get a product. If you get negative 1, then you know that the slope's perpendicular. You don't necessarily have to graph it. If you're just given that slope and you multiply them together and you get negative 1, yes, they're perpendicular. Let's look at one more little exercise. Right here, I've got some slopes listed, so let's find their perpendicular slope. If I have 2/3, what can I multiply 2/3 by to get negative 1? Okay, let me show you this little trick. What I do is I flip this over and I negate it, meaning I make it the opposite value. Because remember, one slope has to be positive, one has to be negative for perpendicular slope. So this one's positive, I know this one has to be negative, and just flip the value of that, 3/2. So I know that 2/3 times negative 3/2 equals negative 6 over 6, and that gets me negative 1. All right, let's do another one. I've got negative 5/6. What is slope that's perpendicular to negative 5/6? All right, you have to have a negative slope and a positive one. This one's negative, so this one's going to be positive. And then just flip it. Flip the value, 6/5. There we go. How do I know I did it right? If I go negative 5/6 times, multiply them together, 6/5, that gives me negative 30 over 30, and that's negative 1. So I know that that's perpendicular slope. All right, one more before we're finished. If you have a whole number, what I like to do is put that over 1. All right, what is perpendicular slope to that? Think about that. This one's positive, so one of them has to be negative. This one's going to be negative, and then flip it. So that gives me negative 1/4. So when I multiply these two together, 4 over 1 times negative 1 over 4 gets me negative 4 over 4, and what's the final answer? Negative 1. So that's just one way, without graphing, to find perpendicular slope. That's our lesson for today. I'm Mrs. Neill. Thank you for listening.